Did you know that we're about to see a once-in-a-lifetime explosion, a firework display of celestial proportions? And as the description might suggest, the drama doesn't unfold here on Earth, but rather up in space.
If we're lucky, in the next few months, we're going to have the chance to observe what we call a nova event, which is the thermonuclear explosion of a star in a binary system.
The stage upon which this drama plays out is the constellation of Corona Borealis in the northern sky. If we zoom into this part of Corona Borealis, we can see this relatively unassuming dim star. This is a binary system known as T Coronae Borealis, or T CrB for short. But you may also hear it referred to as the blaze star.
This particular system is composed of a small white dwarf and a big red giant star. The big red giant star transfers mass to the white dwarf. That mass that is transferred is mainly composed of hydrogen. Hydrogen is a very volatile element, and when it's hot enough, it starts to create nuclear fusion, and then hydrogen becomes helium. And enough energy is being released, those outer layers of hydrogen just get ejected at velocities ranging between a few hundreds and a few thousand kilometers per second. And that leads to a sudden increase in luminosity in the system. That's what's going to be leading to the nova event. And that will be seen in the sky as the appearance of a new star.
During the eruption, it gets bright. So bright that you should be able to see it with your naked eye. So, how do we know it's going to explode? T Coronae Borealis is what we call a recurrent nova, and it regularly explodes every 80 years or so. We've seen it happen in the past, and tracing forward, it's about due to happen again.
We think those systems have regular explosions in a quite predictable way because the accretion rate from the big red giant star occurs in basically the same way over and over again. So after the nova explosion happens, a lot of material is ejected, but then the red giant star starts to accrete matter again at approximately the same rate. So the time you need to build up enough hydrogen to create the explosion is roughly the same. This particular system had an explosion around 80 years ago, and it was very accurately recorded in 1946. The astronomers discovered that 1 year before the explosion, the luminosity of the star dimmed. That happened around 1945. So very recently, the astronomers discovered that this system had again the same dip. So we anticipate an explosion in the next few months.
Long story short, we don't know exactly when it's going to happen. It could be tomorrow, next week, or maybe even sometime next year, but it's likely to be between now and September. So, here's how to spot it for yourself when it does.
The blaze star is in the constellation of Corona Borealis, which will be visible in the evening sky from the northern hemisphere until late November or early December. This series of animations, made with the Stellarium software, shows a view of the evening sky looking towards the west from Exeter in the southern United Kingdom every couple of weeks until December. The location of T Coronae Borealis, the blaze star, is shown by the rotating circle. The view should look similar from any northern hemisphere location at the same date and local time, but for locations closer to the equator, this view shifts towards the northwest rather than the west. As the weeks pass, you can see that the blaze star will be lower in the sky at dusk, and it will set in the west earlier in the evening. If the nova occurs over the next couple of months, it should be visible until at least midnight from most of the northern hemisphere, and if it occurs before mid-November, it should be visible for at least a couple of hours after dark from most of the northern hemisphere. From latitudes near the equator, such as Singapore, the nova should be visible in the early evening sky, looking northwest, if it occurs before late October. But it will become increasingly difficult to see from more southern latitudes. For example, from Auckland, New Zealand, the nova will probably only be visible if it occurs before early October, for a short time after sunset in the northwest. From October onwards in New Zealand, the constellation of Corona Borealis will be in the daytime sky, and so the stars will not be visible. If the nova occurs from mid-November onwards, it will also be visible in the early morning sky before sunrise from the northern hemisphere. Usually the blaze star is much fainter than can be seen with the naked eye. When the blaze star does erupt, it may only be visible with the naked eye for a few days before it fades again. Over the next few weeks, you might like to find the constellation of Corona Borealis in the sky so that you know what it looks like before the nova occurs, and you can locate the blaze star when it does appear.
Here, in the Astrophysics group at the University of Exeter, we're excited to see T Coronae Borealis for ourselves, and we may even make it out to see it through our telescope. We'll be sure to keep you up to date and let you know when it finally erupts, and we hope that you'll join us. Until then, take care.